There is a flight you have probably taken without knowing what made it possible. A direct route between two cities that 10 years ago required a connection through a hub. A city in the middle of the country linked non-stop to Tokyo. A smaller European airport connected overnight to Southeast Asia without a layover. You clicked, you booked, you flew. You never asked why that route suddenly existed. The answer is one aircraft, the Boeing 787 Dreamliner. And the story of how it got there is not just about engineering. It is about a bet that nearly every expert in aviation thought was too radical to work. The dominant logic of commercial aviation for most of the 20th century was simple. Bigger is better. Fill a 500-seat aircraft between two massive hub airports. Move volume between London and Dubai, New York and Tokyo, Frankfurt and Singapore. The hub-and-spoke system was efficient at scale. It was also, for the passenger, frequently miserable. A crowded layover, a connection that added 4 hours, a route that got you close to where you needed to be, but never quite there. Boeing looked at that model in the early 2000s and decided to build something different. Not bigger, smaller, and more efficient. An aircraft that could connect 250 to 300 passengers directly between cities without needing a hub in between, and do it profitably on routes that could never fill a 747. To make those thin routes work, Boeing needed an aircraft 20% more fuel efficient than the wide bodies it replaced. That number sounds like an improvement. It is not. It is a revolution.
At the fuel costs and flight distances involved in long-haul operations, 20% is the difference between a route that loses money and one that makes it. It is the difference between a non-stop service and a connection. It is the difference between a direct flight existing and not existing at all. To get there, Boeing built the 787 primarily from composite materials, carbon fiber reinforced polymers, making up 50% of the aircraft by weight. Every commercial aircraft before it had been built primarily from aluminum. The industry knew composites were stronger and lighter. What it did not know was whether they could be manufactured at the scale and consistency commercial aviation demands. Some engineers inside the industry quietly questioned whether Boeing was moving too fast with a material whose long-term behavior under tens of thousands of pressure cycles was not fully understood. Boeing pushed ahead anyway. And that decision, to commit fully to composites at a scale no commercial manufacturer had attempted before, is what separated the 787 from every wide-body that came before it. Not incrementally, structurally. The aircraft that emerged was not a refinement of existing technology. It was a different category of machine, built from fundamentally different principles.
Boeing's answer was automated tape laying. Massive robotic systems that wrap continuous carbon fiber tape impregnated with resin around rotating fuselage molds with exact fiber orientation. The fuselage emerges as a single continuous section, not 1,500 aluminum sheets riveted together with 40,000 to 50,000 fasteners. One piece. The seams, the joints, the surface imperfections, gone. Drag reduced, weight reduced, strength increased. The consequences for the passenger are real. A conventional aluminum fuselage cannot be pressurized above an equivalent altitude of 8,000 feet without increasing fatigue risk at window joints over time. The composite fuselage is immune to that mechanism. Boeing pressurizes it to 6,000 feet. 7.3% higher cabin pressure, measurably less physical cost on a 14-hour flight. The windows are 30% larger than comparable aluminum aircraft, made possible by the same fatigue immunity. Electronic dimming replaces the plastic pull-down shade.
The engines complete the picture. The GE NX turbofan achieves a bypass ratio of approximately 9:1. 9 parts of air moving around the core for every 1 passing through it. That ratio drives fuel efficiency and reduces jet velocity at the nozzle, which means less noise. The 787 cabin is 60% quieter than comparable aircraft of the previous generation. The chevron sawtooth pattern on the engine nacelles breaks the shear layer between exhaust and ambient air into smaller, controlled vortices, addressing noise at the source rather than through heavy acoustic insulation in the cabin walls. Less insulation means less weight, which feeds directly back into fuel efficiency. These factors compound. Lighter fuselage, lower drag, more efficient engines, less insulation weight, each improvement multiplying the others. The 787-9 burns approximately 5 gallons of fuel per nautical mile on a trans-Pacific route, against roughly 6.2 gallons for the 777-200ER it often replaces. On a 14-hour flight carrying 254 passengers, that is approximately 2,500 gallons saved per flight. Annually, per aircraft, the savings exceed $1.9 million on a single high-frequency route.
As of February 2026, the 787 program has received 2,365 orders and completed 1,257 deliveries, the best-selling wide-body in aviation history. Denver to Tokyo, Perth to London non-stop, secondary European cities to Asia with no layover. These routes exist because the economics finally worked. And the economics worked because an airline no longer needed to fill 400 seats to justify flying them. The 787 made 250 passengers profitable on a route that used to require 400. That shift did not just change which planes airlines bought, it changed which cities got connected, which airports grew, and which passengers stopped spending 4 hours in a hub terminal they never wanted to visit. The hub-and-spoke model did not disappear, but the 787 opened a door beside it, and through that door came an entirely different kind of network.
None of it arrived without cost. Manufacturing quality issues caused a near-total cessation of deliveries between January 2021 and August 2022, while Boeing repaired structural shimming problems, small gaps at fuselage joints incorrectly assembled in some aircraft. In 2024, a Boeing engineer alleged publicly that these issues were more systemic than disclosed. Boeing rejected the claims. The FAA investigated. On June 12, 2025, the 787's first fatal crash, Air India Flight 171, ended a safety record that had stood for nearly 14 years. A preliminary report did not recommend specific actions against Boeing or its operators, but the investigation continues. The Dreamliner's legacy is not yet written. What is written is the route map it created, the cities now connected that were not before, the passengers who landed direct instead of transiting through a hub, the economics that made thin routes viable and therefore real. An aircraft does not earn 2,365 orders by accident. It earns them by doing something the alternatives cannot do, consistently at a price operators can justify. Boeing pushed every chip across the table. The Dreamliner is what came back. If you love aviation and the engineering behind it, subscribe to Aviatales for the latest aircraft stories, technical breakdowns, and industry analysis. Hit the bell so you never miss a video. See you in the next one.